Okay, great. So I'm here to talk about continuous integration, continuous bounties. So this is a presentation based on bugs that I've found in real-life CI/CD pipelines that I've got paid for because I'm a bug bounty hunter. So in this presentation, as I say, I'll outline my methodology for finding bugs in CI/CD pipelines. I'm not going to touch framework bugs, CVEs or anything here. They're all there, we can all go find them. I'm more looking at logic issues, implementation issues, configuration issues that can be found in any CI/CD pipeline out there. I'll detail some of the tooling I used, so I think that's really valuable. Mostly my tooling, so mostly self-promotion, but you know, it's pretty good. I use it and it works for me, so I'll show you some of those. Who am I? That is me. I spent far too long on that little image there. As I say, I'm Chapman, and I'm a full-time bug bounty hunter. I've been doing this since January this year, and it's going pretty well so far. Been in security for 12 years, pen tester for 10, internal security, and on the vendor side. So I've kind of done all around, and I've presented here previously, DEF CON and Black Hat, some cool stuff. So if you're interested, go look it up. And I'm AJX Chapman on Twitter. So firstly, I guess, what am I talking about when I talk about a CI/CD pipeline? So these, obviously, back in the day, used to be programming away and compile on your desktop because we didn't have laptops. And you would go get a coffee, go get another coffee, get at the pub, come back the next day, and probably still be compiling. So we then offloaded kind of compilation efforts to build servers so we could do other stuff on our desktops while we were compiling stuff. And then obviously cloud and all the rest of it came along, and we thought, why don't we just kind of pipeline this? So that any change I make to the source code will just go off and compile somewhere, and I'll get an updated binary a couple of hours later. So that's kind of what I'm talking about when I'm talking about CI/CD pipeline. The general steps that kind of code goes through when it runs through a pipeline is, well, you've got two things. You've got the actual code you're trying to compile, and then a build definition. And the build definition tends to be pipeline specific, but it'll include all the build steps you want to do and how you want it deployed at the end of it. So when a build's kicked off for any reason, either manually kicked off or triggered by an automated process, a build instance will kick up. It will grab your source code from source code manager or something, and then start running the build. If you've written some tests in there, it will run the tests and let you know the kind of success or failure of the tests. If all the tests succeed, it will store the artifacts in an artifact factory or deploy them straight to a server if you've got that set up, and obviously the instance will get torn down. And just looking at this, you can see it's quite a complex set of interactions between many different systems, a number of different technologies. So there are going to be bugs. There are always going to be bugs, and it's a really interesting environment to go bug hunting in. So when we're talking about bugs, obviously the kind of pinnacle of the bug is getting RC on a server. That's not really what we're looking for in CI/CD pipelines. They are command execution as a service. What they're meant to do is run your commands, run your builds, run your code if it's running tests. So we can't just report RCE and go home, unfortunately. These three examples on the screen are from three popular CI/CD pipelines. So Travis CI, Circle CI, and an open source CI/CD pipeline called Screwdriver, all showing that actually in the docs, in the definition, it tells you how to run commands on their servers. But in order to fully assess a CI/CD pipeline, command execution is our first step. We need to be able to run our own commands to then start probing and looking at for bugs in the build processes. So an outline of my methodology when I'm looking at these sorts of things. So as I said, a build starts with two things. It starts with your source code and a definition file. It'll run through the execution of the build. Somewhere during that build, the build system is going to have to access some secrets. So that could be deployment keys or SCM credentials, something along those lines, internal APIs in order to throw code out there or deploy code. A build system is going to report on its build, whether it succeeded, whether it didn't, the logs. So I'm going to look at that, and it's finally going to deploy code. So the first thing I'm going to assess when I look at any CI/CD pipeline is going to be the build definition. So when taking a definition, it could be taken in YAML format, in XML. I've seen some that just straight up take bash scripts. But any processing that's done on these definition files can lead to bugs. So you've got your standard bugs for looking at YAML and XML, so YAML injection, XXE. They're kind of a bit dull, but they can be there anytime that files are processed. And then you have application-specific checks, what I like to term pre-flight checks. So this could be, you've told a build pipeline that your source code exists on Git, on a private repo. So it needs credentials to go and get them. So it'll check the credentials that you've given it. And this will happen before the build starts, so it can alert you to incorrect credentials before it kicks off the build. It might need to clone the source first before it starts the build. So that's another pre-flight check that could happen. Excuse me. And there'll be a lot of pipelines implementation-specific things. And that's one thing you've got to take on a case-by-case basis. But I want to kind of dive into one of these and talk about an issue I found in real life on a reasonably popular build platform. Unfortunately, I can't tell you which one it was. But so assessing this definition stage and the build system's pre-flight checks, and I saw that it was cloning the repository before the build instance was being spun up. So the pipeline would clone the repository and then pass all of the files from the repository into the build instance. I thought that's a bit funny. Normally it happens in the instance, clones the source. So is there anything I can do there? Looking through the list of supported source control systems, kind of usual Git, SVN, okay, a bit old, but whatever, Mercurial, okay, slightly older. Fine, Team Foundation servers, still used out there. And then, the hell's Perforce? Does anyone use Perforce? I had no idea what, two people, thank you. I had no idea what Perforce was. It's like, what on earth is this thing? So kind of go digging. Perforce is actually quite widely used in the gaming industry for some reason. No idea why, but there we go. So the first thing I found out about Perforce, most source control systems are client-driven. So the client says, I've made changes to these files, push the changes to the server. Perforce server acts slightly differently. It's server-driven. The server requests the client, can I have the changes to that file? I thought, okay, that's a bit odd. So, move on to that, sorry. The next thing I found was the Perforce client. So I was playing around the Perforce protocol here. So I'd written some janky Python scripts and kind of just about doing what I needed to, except for I didn't have the state and the control flow quite right. And then I noticed the client didn't care about the control flow. So the client would say to me, I want to authenticate to the server. And as a server, I would say, okay, sorry, the server should be saying, here's your user challenge, and then the client should respond to that user challenge. But I found out that the client could say, I want to authenticate, and the server would say, okay, give me the contents of this file, which makes no sense in terms of the authentication flow. The client didn't care. It'd be like, fine, server told me to do something, I'm going to do it. And taking these things together, I thought, that's really quite interesting. So that's fine if you're dealing with a trusted, fine. It's okay-ish if you're dealing with a trusted server. But in a CI/CD pipeline, you define the server it's going to talk to. So the Perforce client, P4 client, says to my server, use a login. And I'm going to say, okay, send me the contents of Etsy password. And the client says, sure, why not? I thought that was pretty cool. So that's great. I'm happy with this. This is going well. But why stop there? Where else can we take it? Looking through the list of commands supported by the Perforce client, so you've got your send file, that's great. Move file, okay, that's pretty interesting. Delete file, well, that could be funny. And write file. So now the Perforce client is saying, I'd like to authenticate, and I'm saying, please write this bash RC for me. And that was a very simple way of taking a weird client interaction with the server to full RCE in a pipeline. And this was outside the build instance, so this gave me much more access than just having RCE in a build instance would. So I thought, being the responsible researcher I am, I'd let the vendor know. So kind of email security at on their website, no response, no security text, okay. Twitter. Does anybody have a security contact at? But love those tweets. Somebody from their support team gets in contact with me, share the details of vulnerability, and then the response from their development team comes back saying this. Blocking the server's ability to write to arbitrary locations would impact application functionality. Great. However, there is an optional environment variable that you can set to restrict the client, the path that the P4 client can speak to, and that's that P4 client path there. Except it doesn't actually work the way they think it works. I can't go into details of that, but tell me they're fixing it. I'll move on. So that was my first major bug I found in a CI/CD pipeline, and I thought this is pretty good. I'm liking this. I'm going to delve in a bit more. So then I get to the kind of build instance execution stage of my methodology, and this is where it becomes much more like a normal pen test. So you've got your local system build review. So you're looking at differences between a base build of, if it's running on Debian Docker, literally just diff all the files to find out what they've changed in the base build. Sometimes looking for local privilege escalation, depends on the privileges you've been given to start with. Getting root's great, doesn't always get you very much, but sometimes it will allow you to access certain scripts that were read protected from low privilege users. Looking for network services, so what's listening on my local system? Are other build instances listening on those ports as well? How about network storage? Management systems, can I access the Kubernetes backend systems from the build instance, for example? Quick issue there, so one pipeline, I was scanning around their local network, found an NFS share that was exported to the entire network. I thought, great, go and have a look on that, and it's got their container images. So I thought, I took a look at the size, it was 40 gig. I was like, okay, I'm going to ask somebody if I can do this. So emailed their security team saying, hey, I found this, can I go grab your build images? And they're like, yeah, sure, why not? Let's see what happens here. So grab 40 gig out of there and think, great, first thing I can do is try and crack the root password. Couldn't get that. Okay. Did manage to find some early initialization configuration scripts that were deleted by the time your build instance actually starts up. So it's quite a cool way of doing it. They were storing some secrets in there, but deleting them before your build instance started. And that gave access to internal API credentials. Pretty good win. I was like, happy with that. So again, reported that and got that one fixed. Further things can look at in the execution phase. So if we're running in a Docker container or Kubernetes, you do your standard kind of container breakout stuff. There's a great tool by a chap called Chris Leroy, Breakout the Box, I think it's called, on GitHub, which will do a lot of these sorts of container breakout things for you, and pull up very common container issues. And then you've got cross-instance compromise. And this is probably one of the biggest areas of risk in CI/CD pipelines. You obviously want your user data to be segregated, so one user's build shouldn't be able to impact or access another user's build. So a lot of effort should be put into segregating build instances, making sure they can't access via the network each other's SSH instances or other services. So in order to test all of these things, rolling back slightly, you saw at the start we had the YAML definitions. I'm not typing all these commands into YAML and then throwing it to the build instance to build, to come back 20 minutes later for a result. You can start doing that, but it gets old pretty quick. So the obvious thing to do there is just throw up a reverse shell and run it. I didn't want to use Metasploit or Meterpreter doing this, so I kind of thought it was a bit overkill. So looking at a lot of the kind of netcat reverse shells that are out there, and they're all very basic. And then I was working on one pipeline where actually some of the data would have been very sensitive that I was pulling out. I was like, okay, don't just throw it over netcat because it's not encrypted. And then I suddenly thought, well, why can't you do the same thing as a netcat reverse shell using SSH? Quick script later, and I wrote this very hacky tool to do this. So it takes your standard kind of FIFO input-output into SSH. Will connect to an SSH server, which you can then connect to from your server. So the SSH server brokers the connection for you, and you get a full interactive SSH shell, which means you can also do things like SCP, port forwarding, and have full job control on there, which is really quite nice in terms of assessing an internal environment. So I thought that was quite cool. Throw that there. It's on GitHub. Feel free to check it out. So looking at cross-instance compromise is, as I say, is a really big thing and a really high area of risk. So when I'm looking at this, you want to see all of the processes that are running on your build instance, all of the network services that are going to be running on your build instance. In this particular case, I saw there was a debug service running on a high port. I thought, fantastic. I didn't quite know what it was, so grabbed the binary and the debug binaries, tried to replicate it on the local system, do some. This seems to be simple enough. On my local system, I could use the debug service to call arbitrary functions within the debugged binary. I thought, great. But it didn't work in place. It didn't work in the pipeline. So obviously get more frustrated, and then figure out the way they were launching it in the pipeline. It had no interactive threads to run any of the functions that normally you would be able to call. So kept kind of poking at this. It was one of those things that kind of just doesn't feel right and doesn't feel like it should have been able to, or should have been accessible, certainly. So I found out the debugger was open source. So obviously go to the source on GitHub, and then found what I term a semi-vulnerability. So it was an arbitrary memory read in a project that was actually a debugger that should allow you remote code execution by default. So it helped me in this case. So I could actually dump all of the process memory from a remote build instance and extract environment variables, which included great things like usernames and API keys, and API endpoints. So that was pretty cool. I went to report this bug, and it could not be reproduced. I was like, okay. I was doing this 20 minutes ago, so I can do this. I spin up my instance again, and when it happens again instantly. Okay, what's going on? Fire it back to the security team, and they're like, yeah, no, we cannot reproduce. So I showed them my entire terminal output. They sent me their terminal output, and they're like, yeah, we can see the bugs there, because you're doing it. We can't reproduce it here. And it turned out in one of their data centers in Northern America, they hadn't implemented network segregation. In the other 7, they had. So I just managed to stumble on the one data center where they hadn't got that particular segregation in place, which pretty lucky for me, but yeah. So in the end, they were able to implement their segregation. I think they also did host-based segregation or host-based lockdown of this port and network segregation in that data center, which is pretty cool. So in terms of secret management, in order to do anything interesting, a build instance is going to have to access secret data. So as I said at the start, this could be source control management credentials. It's got to be able to clone the source, unless it's given the source some other way. It's going to want to deploy the source somewhere, whether it's to an artifact factory or to a server. It's going to want to report log files and success failure of tests. So in order to do all of these things, there's going to be some back-end APIs, or other systems that the instance is going to have to access via credentialed source. So we want to look at how they're accessing secrets and how they're accessing these credentials and storing these credentials. So Cody covered in his talk metadata services. So if these are running in AWS, you see if you can access the AWS endpoint. Container services also have their own metadata endpoints, so you can try and access Docker endpoints. Already mentioned the Docker SOC when looking at container breakout, or Kubernetes backends. Virtual machine config is one that I didn't know about that I'll cover on the next slide. Execution environments as well, so they could be storing secrets in custom scripts. So that could be on the network, that could be on the system, removed from the system before startup, as I mentioned, or it could just be locked down in a directory that you, as a low privilege user, you can't access. They could just be storing secrets in process environment variables. I've seen it in more than one case where they store API keys in a parent's process environment variables. So in your running instance, if you just run env, it doesn't show you any secrets. But if you check the environment of the parent process, you'll see the API keys. That was quite a sneaky one, but always worth checking the environment of every single running process that you can access. And then internal APIs. So I had a great instance of a build pipeline that would access an internal API using a single set of credentials across the entire build pipeline, and that API would then give you the credentials that you were supposed to have. But you had the credentials to access the API, so you could get anybody's credentials, which they didn't really think that through. But it was the virtual machine metadata that really stuck out to me, because I'd not seen this one before. So VMware has this thing called guest info variables. And I did a lot of Googling on this, and it's really esoteric. There's a few weird posts on there and a few very limited VMware help documents, but this functionality is there. So I saw a configuration script with the command saying VMware tools daemon command info get, and then a guest info variable name. And I eventually worked out that these guest info variables were just set in the VMX configuration files as guest info dot whatever you want. And this would then be able to expose that value to the internal virtual machine via VMware tools. I thought that's pretty good. So we had this API URL. Try to access it, credentials required. So doing some more Googling, cannot for the life of me find a way to list all of these guest info variables that are available to a machine. So what do you do? You script up a quick brute force with a word list. I say quick brute force. This is running, give or take, natively, so you can brute force several million of these in a couple of minutes. Ran through a massive word list, and obviously probably could have guessed that without actually running through a word list. But the API user, API password came out, and I thought that was really cool. That was one that I didn't know about before going into this. That was available to VMware virtual machine guests to store. Obviously, you shouldn't be storing credentials there, but to storing some information. Looking at reporting, as I say, build instances are going to want to report their build logs. It's all very well saying the build failed, but you want to know where it failed, why it failed, what the error message was. So somewhere, there's going to be an accessible build log. You might be able to set up web server hooks. So you only want to know, be pinged via a webhook if your build fails, and then somebody can go and investigate it, or Slack, or something like that. As an aside, there was some really good research into CI/CD pipeline build logs done by Justin Gardner, Corbin Leo, and Ed Overflow. If you've not seen that blog post, check it out. Some really cool stuff going on there. One of the kind of more subtle points that is drowned out a little bit is they were also checking for third-party packages that didn't exist. So they were looking for NPM packages that were being pulled into a build that didn't exist. So then they could, in theory, go and register them and gain code execution in somebody else's build, which I thought was really cool. But it kind of stuck as a side note at the end of all of that research. So just as Cody has written himself a really cool DNS and HTTP server, I've done exactly the same thing. This has been years in the making though, and it's still really badly documented. So my tooling that I use for anything SSRF is called research servers, again available on GitHub. And it allows me to very quickly create custom HTTP servers to do loads of stuff. I'm running very close to time, so I'll run through this very quickly. Looking at a vulnerable webhook that I found. So this was some Ruby code. It gets the URI hostname address, makes sure it's not in, so in this instance, resolves to 888. Checks it's not localhost, loopback, localnet, or link local, and then requests the URI. What happens if the DNS changes between those two checks? So this was one area we're using classic DNS rebinding. This was actually in Ruby, which doesn't have a DNS cache, and you could set the TTL to 0. So it didn't need to do any cool stuff, but that was quite a fun one I found in a major CI/CD pipeline. And finally, the last stage we're going to be looking at is deployment. So how are artifacts stored? Where are they stored? Are they namespaced correctly? Are you allowed to place artifacts into different namespaces? And are they access controlled? More often than not, from a CI/CD pipeline, you can access all of the artifacts from within the build instance. And then how are builds actually deployed? So how are the keys for a build managed? I don't have any examples for that, and I am running out of time. So I'll finish on the summary. That's my methodology there, looking at the definition, execution, how secrets are handled, how reporting is handled, and how deployment is handled. These are very complex systems. There are bugs aplenty to be found in them. I'm Alex Chapman. I'm AJX Chapman on Twitter, email, HackerOne, GitHub, LinkedIn, probably other places. Thank you, 44Con, and thank you, HackerOne.